All right, ladies and gentlemen, so we're going to go over this pop quiz. 10 questions, starting with number 1. The most common answer to this question was like 17x or 27x. What people seem to do is they distributed the 3, and then they thought they had to add. They thought there needed to be more to it. But here's the total solution. We just distribute, multiply the 3. All I'm asking you to do is distribute. I didn't say solve. There's no equal sign here, so there's nothing to solve for. So 3 times 4x is 12x. 3 times 5 is 15, so it's plus 15. And these are dissimilar. You cannot combine 12x with 15. So sometimes I've taught students to use shapes. You can't combine the circle different from the triangle. Okay, so that's just the full answer. That's it, 12x plus 15. A lot of people wrote that as a as part of what they did, and then they continued, and it was clear that they didn't know what was going on. So now on number 2, the first step is to draw this vertical line with the protractor, please. Let's try to look like we're a machine. All right. First step, subtract this 3 on the left from both sides. Use your protractor. Minus 3, minus 3. Line, line. Mirror, mirror on the wall. Okay, mirror. Everything's a mirror image. Now, 3 minus 3 is 0. Those are additive inverses. So we see how I used the edge of my straight edge to make a straight line. Now bring down this negative x. This was in that people dropped this negative sign like crazy. Negative x equals. Now the most common thing people wrote was 0, but that's not true. Negative 3 minus 3 is negative 6. So negative x equals negative 6. Therefore, positive x equals positive 6. Box. You're done. Not too bad. I saw a lot of people on the right track here. I saw a lot of people write 1 over 24. A lot of people wrote 24x. So you knew something 24 was involved. Here's what you're supposed to do. Cross out the 3 and the 72 and divide 3 by 3. You get 1. Divide 72 by 3, you get 24. But what a lot of people dropped was the x. They thought, I guess the x just disappeared. No, it's still there. So I counted the following answer correct. 1x over 24. Still, we don't write the 1. So we write x over 24. Our final answer. A perfectly valid alternative answer that one person put was 1/24 x, kind of like it was a slope value.
I need freshmen N through Z with your Chromebook or Acer book and chargers, please. Thank you.
So these are both valid answers, guys. Okay. One of these days, if I remember, I'm going to do a whole worksheet with like 50 of these where I give you like x over 5 and then you have to write 1/5 x, or negative x over 2 and you have to write negative 1/2 x, just so we know these are equivalent. Okay. Number 4, prime factor 42. Most of you did good on this. Break it down into, here's your primes, 2, 3, 5, 7, 11, 13. You won't need anything higher than that. So we start with 2 since 42 is even. 2 times 21. 21 is called a cofactor. So this is a prime factor, and this is the cofactor. They're called co because they work together, like a co-worker. Break 21 down. Well, 21's odd, so I'm going to look at 3 as my possible prime factor. My cofactor is 7. But guess what? The cofactor is also prime. So now I've got my primes. In other words, every number I just circled is on this list. And here's what I wanted you to do. If you did that, I either gave you 5 points out of the possible 10, or I just counted it right. I was somewhat inconsistent on how I graded that one. But what I really wanted you to write was the product of the primes, such as this. That's what I really wanted. I want you to learn how to break numbers down into their primes. That's another thing where I need a whole worksheet of about 100 problems, where that's all you do is just break numbers down. So important. It's going to come up later in this paper. Okay. Today is the last day that any of you will get a question like this wrong. This number right here. What is this number? It's the y-intercept, ladies and gentlemen. So today's the last day. Let's celebrate. Today's the last day anyone is ever going to graph a simple linear equation incorrectly. This is the y-intercept. What that means is you're going to go to the origin with your pen or pencil, and you're going to go 1, 2, 3, 4. Put a dot there. I always label everything. Label it 4, and then make sure you label that that's the y int. So you know, okay? Now, keep your pen or pencil on that dot, and you look at this number here. This is the slope. Now, this top number is the rise. So, and the bottom number is the run, and we always run to the right. So we're going to go up 2 over 3 to the right. Okay? We're going to rise up like Andra Day sang. Up 1, up 2. You guys know that song? Over 1, 2, 3.
I know that song.
Mm-hmm. And we go to the right. We run to the right. And then you notice I'm taking my straight edge. I'm going to very carefully line it up. And I'm not going to do this. Here's what I saw people do. What is that called? It's called a line segment. That's not a line, okay? That is wrong. This is a line. A line has to go into infinity in both directions. So you need to extend that line out, and you need to put these arrowheads. Got to put your arrowheads. This is a First Nations. I love Native American culture. The most common mistake people made here, people made a good faith effort. The most common mistake people made is to write it over 100, okay? That's a mistake. And that's a mistake because it's a repeating decimal. So we can't write it over 100, we have to write it over 99. And that was the most common mistake. So let's just write 78 over 99. Well, 9 plus 9 is 18. That's called the digital sum. What's that called? Digital sum. Well, 18 is divisible by 3, right? So by the law of, or the rule of this little trick that I'm teaching you, if the digital sum is divisible by 3, then the original number is divisible by 3. Well, what's 99 divided by 3? So cross out the 99 and put 33. What do you think the odds are that 78 is also divisible by 3? Good? Very high? 7 plus 8 is? What's 7 plus 8? 15. Is 15 divisible by 3? 78 is divisible by 3. I love this trick. This trick has saved me many times. Now, we don't know what 78 divided by 3 is. Some of you know. But we're going to go over here and we're going to figure it out in side work, okay? Because we can divide. All right? 78 divided by 3. Well, 3 goes into 7 2 times. 2 times 3 is 6. Okay, get that Spanish going here. 7 minus 6 is 1. And then I bring down the 8. Well, 3 goes into 18 6 times. 6 times 3 is 18. There's no remainder, so it's 26. All right? So the reduced fraction, we put in what Michaela's older brother Jay called the red box of correctness. 26 over 33. Now you need this fraction to do number 7. Because look at number 7. There it is again, 0.78 repeating. So right away, we're just going to cross that out and we're going to replace it with 26 over 33. And now we're going to have to prime factor. So we're going to write 26 over 33 times 11 over 13. Just like that. I saw people, for the most common mistake was people just tortured themselves by multiplying 26 times 11 and 33 times 13, and then they just wrote that as a fraction and called it good. Guys, I would not do that to you, okay? You're starting to understand that most of the time I make the problem work out to some small number. So let's take 26 and let's just prime factor it. What should I do? Divide by 2. 2 times what? So those are both prime factors. That was the full prime factorization of 26. How about 33? So put the small number first, 3 times 11. Now, you remember that if I multiply 2 times 13, I get 26. If I multiply 3 times 11, I get 33. So here's the trick. Replace the 26 with 2 times 13. Draw you a bigger fraction bar. Replace the 33 with 3 times 11. Now put times 11 over 13, because we didn't touch that one. Now why on earth did we just do that? Why does that help us? It rhymes with Hansel. Cancel. Look at this. I can cancel the 13 and the 13 and the 11 and the 11. And what's left? You just circle the answer. So if you're looking at your paper and you had like 7,246 over 6,500,000, you know, it was just 2/3, guys.
At this time, sophomores with the PC Bring your
Thank
PC
you.
and charger to the library, please. Thank you, all sophomores.
Okay. So now we're on to a problem that is a legitimately challenging algebra problem. And I put the star there, okay? Because it is legitimately challenging. So first we need to write out the formula for the area of a triangle. Base, B-A-S-E, times height, H-E-I-G-H-T, divided by 2, equals area of a triangle. Let's identify the base. The base is 8, so we're going to write base next to 8. The height, guys, the height is this whole thing here, okay? So we're going to write height underneath it. All right, and guess what the total area is given to us? It's 48. So I'm going to build my equation. 8 times 2, open parentheses, x plus 2, divided by 2. So I drew this big, long red line, okay? Divide by 2 equals 48. Now watch closely. I hate fractions. Do you hate fractions? I hate fractions. I want to kill the 2. Okay, like duck hunt. Boom! So I want to cancel. Cancel. If I want to cancel that 2, which is in the denominator, I need to multiply it by a 2 in the numerator. Right? And I'm allowed to do that because this is algebra. As long as I do it on the right side, I'm good. Okay? So anything is legal as long as you do it on both sides. You understand? So why did I do that? Well, now I can cancel. What was Hansel's sister's name? Gretel. Now let's write 8. So all that's remaining on the left, I got rid of the fraction. 8 times 2, open parentheses, x plus 2, close parentheses, equals 48 times 2. Can I ask a question? What are 2 numbers that you know of that multiply together to be 48? 6 and what? 6 and 8? 12 and 4, right? But let's do 6 and 8, okay? Because here, this is called mathematical intuition. You'll develop. You see this 8 over here? So I want to think about this 48 for a minute as an 8. So what I'm going to write instead of 48, I'm going to write 6 times 8, which is still 48, right? And then I'm going to do this times 2. Okay? You still good? Okay, we didn't multiply it out, did we? Now watch, I'm going to tell you why. This is cool. I'm going to now divide both sides of my equation by 8 times 2. This is a big move. This is like a combo move in Mortal Kombat. Okay? Or that where you hit L2, R2 at the end, and then he does like almost kills him. This is a combo move. I'm going to divide. This is very strange for students. Divide by 8 times 2, okay? Remember, anything is legal as long as we do it on both sides. Now, why did I do that? Because of Hansel. Cancel the 8s. Cancel the 2s. Cancel the 8s. Cancel the 2s. Look at all that canceling. That's my favorite thing about this subject. Now I have x plus 2 equals 6. What's my final step? Just subtract 2? So really, the only math we had to do was to minus 2. Everything else was just canceling. What's 6 minus 2? Quattro. Guess what the answer is? Bruh. That's a bruh answer, right? The whole thing was just a joke. All right, guys, so now let's move on to number 9. So we're doing good. Let's just take a look here at number 9. Now, most common problems that I saw in number 9 were that people seem to forget what x times x equals. So we need to do a little sidebar review over here. Let me just mark off a little area here. Now let's remember something, okay? Remember our rules. This is called the product rule, P-R-O-D-U-C-T, R-U-L-E, the product rule of exponents. And I'll move my hand. Okay, wish I was right-handed, lo siento. The product rule of exponents. So this is what you do in situations where you have to multiply like x times x. And here's what it is. It's x raised to the power of some number, which we'll call a, times x raised to the power of some number, which we'll call b. The product rule says that when you multiply and these bases are the same, these are called bases, okay? B-A-S-E-S. Okay, remember, ladies and gentlemen, it's all about that base in mathematics. So those bases are the same. Then what we do is we just write the base again and we add the exponents up, which in this case would be a, whatever number a was, plus b, whatever number b was. So for our example, you have x, x, x. So just x's. Here's what we need to remember. Whenever you see an x all by itself, there is a 1, a big 1 sitting to the left of it, okay? And there's a little tiny 1 up here in the exponent position. So if it helps you, I recommend going in here and putting in the 1, the big 1 to the left, and the little 1 up here. And I still do this even as a teacher, so I don't get confused, because it's easy to get confused. So now we're gonna distribute. Just gonna use the same distributive property you guys have been using to distribute that x through both of the terms inside this parenthetical expression. And parenthetical means inside parentheses. That's where parenthetical comes from. So we're going to multiply 1x to the first power times 1x to the first power. Well, first let's deal with the numbers. 1 times 1 is just 1. So we'll write 1. Now here I'm going to have to use my product rule of exponents. My bases are the same. X times x, bases are the same. So I'm just going to write the base again. So I'll write x here. And then I'm going to add the exponents. So 1 plus 1, 2. So I have 1x2. That's how people say it. But what we need to learn to say is, we need to learn to say that x to the 2, the way that you say that is you say x squared, like this, x squared. Okay? So we say x squared. Now, we have 1x squared, and now we're going to multiply 1x to the first times 4x to the first. So let's deal with these numbers first. We're going to multiply 1 times 4, and that's going to be 4. 1 times 4 is 4. So we're going to put that plus sign. So we're going to put plus 1 times 4 is 4. Now we're here again. X to the first times x to the first. Bases are the same, so we'll write the base, and then we'll add those exponents. 1 plus 1. Okay. So again, 4x2, but we know that x2 is x squared, so we say 1x squared plus 4x squared. And we'll write equals 125. We better take our protractor or straight edge and draw a vertical line right here. And now we can continue solving this problem. So notice we now have 1x squared and 4x squared. These are like terms, so we can combine like terms, right? So we keep the x squared and we just add 1 and 4 like so. Okay. What's 1 plus 4? 5. So we have 1x squared plus 4x squared is 5x squared. So we'll write that over here. 5x squared equals 125. Okay? So now what we need to do is divide both sides by the coefficient of the variable. So I have the variable x squared. I'm going to divide both sides by that coefficient, which is 5. Okay, so I'm going to divide both sides by 5. Okay. So 125 divided by 5 is 25. So now I have x squared, because I cancel these 5s. I have x squared equals 25. All right. Now I have one final step. This is called squared, x squared. Now, there's a reason that I wanted you to learn to say it like that, because we need to learn the inverse operation of squaring. So the inverse operation, or the inverse of squaring, it's like, how do you undo squaring? Because that's what we need to do. The inverse of squaring is square rooting. Okay? So the square root is this symbol. There's a lot more to learn about that symbol. That's called a radical sign. This symbol here is called a radical sign. And there's a lot more to learn, but we will just, right now, we'll just use the square root that you've already learned about. We're going to come down here and we're going to square root the left side of the equation. And that's so I can get rid of the square. The square root of x squared is x. So over here in side work, I can show the square root of x squared equals x. So the square root of any number squared is that number. And I can demonstrate that. The square root of 16, everybody knows the square root of 16 is 4. But that's because the square root of 16 is really the square root of 4 squared. So we take the square root of 4 squared and we get 4, right? Now, go back to our problem. So now we're going to take the square root of x squared and we get x. Okay? But we have to do the same thing on the right side, just like anything else in algebra. It's only legal if you do it on both sides. So we're going to have to take the square root of 25. And everybody knows the number, it's 5. Now, most of you are going to write down x equals 5, but that's not quite true. It's actually x equals plus or minus 5. Some people said, so does that mean that we don't know? And the answer is yes, we do not know. Okay, we don't know. Here's why. Because 5 times 5 is 25. Okay, so x could be 5 because 5 times 5 is 25. 5 squared is 25. But negative 5 times negative 5 is also 25 because a negative times a negative is a positive. So we have to include both options. So it's really like saying x1, like we have two x's. We have x1 equals 5, x2 equals negative 5. Since that either one of them could be valid, and we just don't know. In geometry, you almost always choose the positive root, okay? But in math, we leave it ambiguous, okay? So we'll just put a big box around all this stuff. And that was an advanced kind of problem. That's why it had an asterisk. Okay, finally, this one really, guys, I gotta say, bruh, on number 10, because we did go over this a lot. And I also put options over here. And people were writing things in that weren't even in this possible choices list. The number to the left of the x is called the coefficient. Coefficient, okay? We're going to come over here and write coefficient. Okay? Now, x is the letter, and that's the variable. Okay, most people got the variable. variable, variable. Okay? Coefficient is coefficient. Now we come over to the other side of the equal sign, we see this number hanging out all by itself. Anytime you see a whole number or a fraction or some kind of number that doesn't have a letter with it in an algebra problem, we call that a constant because it doesn't change. Constant means unchanging. So we're going to call this a constant, C-O-N-S-T-A-N-T, constant. Okay? Well, ladies and gentlemen, brothers and sisters, comrades and friends, fellow countrymen, workers of the world, that is the whole paper. Okay? So let me zoom out so you can see the whole thing. Almost. There you go. And that just looks very mathy. I like it. You know, this is how our papers should look. Very neat, very organized, boxes around all the answers, really clear graphs with straight lines. This is an aspirational document, which means many of us are not yet at a place where we can just sit down and bang this thing out in 15 minutes, but you need to start reaching for this, okay? This is where you need to be, where doing a builder with these types of problems is just not a big deal, okay? But we'll get there. That's what this is all about. This is about practice, and it's about getting better. It's about incremental improvement, okay? So make sure that you watch this video, study this, like if you like the video, comment if you would like to improve the search algorithm for YouTube here. And if you haven't already, if this was beneficial to you and have earned it, please consider giving me that sub by hitting the sub button. Make sure to subscribe to the channel, and I know it's sometimes it's annoying, but hit that notification bell, especially if you're one of my students, so you're always alerted every time I release a new video. Thanks so much.